let's go over. Your lab this week is like 4 short videos and a couple questions on them. Enjoy it. It's about Mario. In fact, let me just bring up the quiz just quickly right now. So there's 4 videos from the PDS Game Show and Idea Channel. Um, Number 3. It's a very subjective question. There's really no wrong answer here unless you don't try. Literally, that's the only wrong answer. You could be, is it weird? Is it not weird? Does it make sense to you? Is it like, yeah, and if you're the type that like, yeah, flowers make me big, man. Don't tell me later on. I don't want to put in a CARES Act because you're taking mushrooms. Yeah. All right. So that's your quiz. All right, your lab. All right, first thing we're going to do is we're going to take the smooth movement. We're going to upgrade it to use what's called the rigid body. We're going to make a rigid body movement class. So we're going to take the parts of smooth movement and we're going to upgrade it. One of the things we're going to do this week is we're going to upgrade input to get input for 2 players. So there will be a player 1, player 2, and then there will be get input player number, and there'll be a player number that we'll give, and that will allow us to switch between. So we'll have the same script, but we can flip between the 2 players and set that up. We will use a move forward function and a rotate player function. I think I've already had you do this already, and we'll be using the rigid body components. So we're gonna use the physics system, and we'll have fun using that up. Where we're gonna go? We're gonna make a soccer game, and we're gonna use a soccer ball. I'm gonna show you the asset store just quickly, just so you know. Hey, if you were to get something from the asset store, what that process. So I'm literally going to import this asset on the fly. I probably will have to recreate the material for this asset for the soccer ball. Because it's if we look at, here's the soccer ball. This is the thing is this was latest release date, 8 years ago. Uni version 5.52. Oh boy, this is a while. I am logged in, just so you know. I'm logged in already, so you'll need to log in to get this. Basically, first click on to add to my assets. And I will accept the term of service and be like, hooray, add it to my assets. And I can open in Unity. I'll open up the editor. Now I have the editor open already, and it's basically like going to bring in what's called the package manager. And literally assets out of the asset store show up under the package manager. They are a package. I'm going to download it. There you go. It's downloading. And then I can import it to the project. And there we go. I will import it. And obviously these 2 materials I'm going to have to rebuild. Hopefully I can rebuild them. Okay. So I've imported it to the project. So now we look. Here is the soccer ball. So again, we look at my here is soccer ball. Let's look at the prefabs. Yeah, so I got to go look at the materials. Has a normal map. Let me go back and let's build. So let's go to Uriel Rev pipeline. It's going to be lit. Kept the normal map and then base map. do this one. It looks like this is not working. This is not what I thought it was going to do. Lit. Yeah, it's not doing what we really want. But we'll be okay. Not the asset I thought this was. I'll try and find another asset, but that's basically the asset store in a nutshell. You first have to add it to your account. Once it's added to your account, you can then, again, the other way to get to the asset is the package manager here. Another way you can get asset stores here, and my assets over here. So there's pieces right here. Package manager, basically, again, I can then add it. I'm going to close this. I'm going to move on. I'm going to move on without that soccer ball. No, I'll use it. I'll use it. Go to prefabs. I put it into the scene. Put it into the scene. This is not the scene we want. I was working on something. Oh, it's shown up correctly now. Oh, that's nice. So it is working. Okay. Well, why I'm not sure, but does it have two materials? It does have two. It does have two materials. Okay. So what's going on is that so basically there are two materials, one that's black and the one that's white. So that's what's going on. At some point, this will refresh, and this will represent. So there we go. So it is working. So we'll use this as our soccer ball at some point. All right. Let me go through. Oh, I can close this now. So basically, we're going to create a soccer ball. We're going to give it a rigid body. The one thing about we'll give it a script. And the big thing about the script is that we're going to know its starting location, its starting rotation. It will have a rigid body component, and we'll have a reset object function. And we'll go over that in when we do the script. We'll build a soccer net. Soccer net will basically have a collision area that's a trigger. We'll talk about what a trigger is, how to set that up. And we'll also write a script for the soccer net to know when the ball goes in the net. And I think, I'm not sure if we have it, but I think we'll give it a team number on this as well, just so we can say, hey, team 1, this, team 2, that. The goal this week is that you've got a character basically that's using the rigid body movement. It can hit the ball by bumping into it, move the ball around, and put it in the net. All right. So let's talk about the collision system. All right. So we've got 3 packages right now. The built-in 3D system has been traditionally PhysX. There's a 2D system using Box 2D. This is a data-oriented technology stack. This is another way to build things. They're using Havoc right now. So components that are 2D specific to the 2D and dependent to each other, don't mix 2D and 3D. So don't. That's the big thing. There is a name. There's a function that will be named this, and then another version that has 2D appended to it. They don't work together. So don't mix 2D and 3D. All right. In order for a game object to use Unity's physics system, requires 2 components: a area, the collision, and it defines the solid area of the collider or the volume of a trigger. And the other piece is that there needs to be a rigid body in play. One object has to have a rigid body, not both. So basically, like the ball is going to have a rigid body. It's going to go in the net. The ball has collision. The net has a collision area as well. Here is documentation on those pages. So just, update methods. There is, so there's 3 update methods you should be aware about. There is update, which you're normally going to use, and we're going to use update for our purposes. If there's something going on with the physics system that was funky, you would use fix update to do your calculations there, to do physics calculations. So this is the ticks based on physics. Late update. This is called all update methods are called. So this is great for setting cameras. So if your camera is like kind of jittery around, you could use late update to get a better non-jittery position. So there are what these call timing functions, and these are the, you've seen begin, you've seen start, you've seen update, fix update is here, late update is here, and you'll find a couple more that you'll use on a regular basis. Awake is another one. So when the object awakes, it does this. So the rigid body itself is a component. This is where you can define its drag, its mass, angular. Is it using gravity? Is it kinematic, which is you don't want to turn on most of the time? How does it interpolate? And there are constraints. Note here that you'll want to open this up. I've got it in the where we freeze the Y on the position and freeze rotation. This is how we're going to set our player. We don't want it to move on the y-axis, so we don't want it to go up. And we don't want to move, we don't want the physics system to play with the rotation of the object. I'll do this wrong the first time, and we will see what happens. And I'll have a little laugh. We'll make a joke about soccer at the same time. And you see what happens. I've kind of gone through here. So rigid body, so the big one is that the code here is linear velocity. So we get the rigid body component and we set the linear velocity. Older code, this was just called velocity. So just if you see older code, you see rigid body velocity, make it linear velocity now. That's something they've changed with Unity 6. Sets the direction speed of the game object of the rigid body that it's, the game object rigid body that it's attached to. So there is add force, and basically there's a force mode that you can add. This is like adds a force the game object is attached to, has a default value, so you can exclude it. So you can just do add force the direction you want to go. All right. It's important to check that we have a valid component in our object. It's important to, after getting a component from a game object. So when we ask for a component that doesn't exist on a game object, so we use get component T, and this is was in so this was on your quiz, and it was in documentation given to you. It was in a file. One of the files. So we can ask for a component by using get component. There are two ways we can check. We can check code two ways in Unity. The first one here, we're getting rigid body get component rigid body. We can do ask if rigid body is equal to null. So we don't. So when we're dealing with objects, we're dealing with references. And if we don't have a reference to an object, we have the value will be a null. So like gamepad, keyboard, mouse, these are objects. Structure extent can also be that way, but basically we're dealing with objects here. In this case, if a rigid body is equal to null, we don't have a rigid body. In Unity, we can use the reference of a component in a if statement. So we can say not this component, the value. So camera, we're looking at rigid body, which is the component. We are looking at camera, your light component, going down the mesh renderer is a component. Your scripts are components. So this is important here. We're going to use this, and this idea that we are checking. We ask for a component and then we check for said component is going to be one of the key pieces of our tool chest. It's going to be a key piece of your tool chest across multiple languages as well, to be quite honest. So moving on. In this case, if it without this, again, we're going to use this version because we're in Unity. But you have seen this already because the the gamepad, these are device classes and they're not components. So that's why we had to go is not equal to null in those and did our work. Sometimes it's easier to require a component. The rigid body is a great example. So there is a require component. I got double. And require component is the first time you've seen an attribute. Basically, this is they're metadata properties you can add to a class. You won't see many of these, but they're next week, I think it was either the next week or the week after that, when we look at raycasting, we'll see another attribute. So here is looking at the collider. Big one. So again, we'll move on from the big thing about colliders. You need to think about this is that they are either when a collider is either solid or it is a trigger, and a trigger basically has no collision. In terms of affecting, like, it's not a wall you go through. A trigger is an area that you can enter into, and they're also technically the collider itself is invisible. Now we'll look at the building the collider, building colliders and building things with triggers that you can see. We'll talk about that when we get into the engine. But basically, edit collider basically is just you can change the size of the collider. So it's not, you don't have to have your collider the same shape as like a cube. And we you can in some cases, and again, by default, if you put down like a cube cube collider, and you put down the standard cube, that the mesh of the cube is the same shape of the collider. I should say the collider is the same shape of the cube. And so you change the shape of the cube, the collider goes along with the changes as well. So that's something you can use to your advantage. Same with sphere collider, the capsule collider. So typically these objects are gonna the collider is gonna match the shape. Doesn't have to. And later on, we'll look at scenarios where we will be using multiple colliders. You can set physics materials to colliders, and that dictates how they act with other surfaces. The idea is like I'm a tire and I'm on ice. I should behave this particular way. I am wood and I'm moving across grass. It should behave this way. In terms of the physics between those two surfaces. Center is the center of the physics for the center of the physics calculations, and the size is basically the size of the collider. Some colliders have exact properties to just shape and size. So this is where we've got other properties beyond, capsule collider has center and radius and height. The cube is going to have, the side of the cube effectively. So sphere is going to have a radius. So you will see things, different properties based on the different colliders you're playing with. All right, mesh colliders. We've played with them once already because there was a need for it. Just a reminder now that we typically do not use mesh colliders as a default. Because basically what we're saying is that every single polygon on a model is going to be checked for physics. And so you're not going to do this on like a cinematic model. That's going to take forever to do. In fact, you might lag out your system doing that. And I think there's also a severe limit on the polygons allowed as well. And so there's better practice performance using multiple colliders. Just talking about physics materials, and this is just I'm going to go through the properties. How do they combine friction, bounce properties? What's the bounciness, static friction, dynamic friction? Does it have bounce? So these are all right. Let's jump. I'm going to go past them pretty quickly. I'm just going to move on to the collision methods. So there are 3 methods you're going to be looking for on a regular basis. On collision enter, on collision exit, on collision stay. So this is rigid body hits another rigid body. They're both solid. Trigger methods. This is what we'll use with the net is on trigger enter, on trigger exit, and on trigger stay. So enter, something has just entered the trigger. On trigger exit, something has left the trigger, and then on trigger stay is it's still inside the trigger. Note that all of these methods were again these are get these so when the system gets sees a collision sees a trigger happening, these functions return back a collider, which we will refer to as the other. Now that we got the collider, now what? We can go other game object and get its name. We can use other game object get component. This week we'll be probably using get component. This is the end of the slides. There is another variant on get component. It'd be get component and parent, and we'll talk. I think later. I think we'll talk later on. We'll talk more about that later on because we'll talk about, hey, I have this multi-object game object that's consisting of multiple objects, and the collider is not the parent. What do I do now? We'll talk more about that later on. But this week, right now, we're going to keep it simple. So let's move on. Let's get into Unity right now. All right. There is a package actually I need to show you. There is a URP soccer package, and that will, if we go to our assets, it will come under common assets, and it will come under prototype. Here it is, soccer. So I'll give you this prototype soccer. I've got more folders, so hint, there are more folders coming. There's more packages that I've made. So I've converted all the packages for this class. So later on you'll see examples here. Let me there we go. So I've got just go, there we go. So later on you'll get some packages that will show you there are examples of different things. So I talked about that raycast. I'm in the exit. This is the end of the course where you've got where we're exiting the application. How does a button exit the application type stuff? That's weeks from now. So that's what you're looking right here at the moment. But later on, like today, you're gonna get the soccer. Next week you'll get Plinko and you'll get combat. The one thing in soccer. So let's go into the soccer. And it has two models. So I'm basically going to go make a new scene. So let's create new basic. Don't save. And I'm going to go file and I'm going to save as. Now I have made a folder for the class right now. Do I want to leave this here? No, I actually want to go. So for our purposes this week, I made a folder called application, because later on you're going to make a small game that's going to basically, you'll have a main menu and then you'll have, so basically in here, I'm just going to make a new folder called soccer. And I'm just going to shove all the scripts that I need for soccer into that folder. I'm just going to give you, just so that we're prepared, there is Plinko. We'll talk about Plinko next week, and then combat. We'll talk about those two next week. There will be a video. The videos explaining what those two are. And I'm just going to call this soccer. All right, I'm going to take out the main. So I'm going to drop in this open arena prefab and put that at 000. I have found that it's useful to cut the scale in half, just for purposes. You'll see that it comes in, it's already textured, and it's using the textures already here. Do delete the directional light and main camera, and that's because it already has the main camera and a directional light built into the prefab. So this is just, hey, you can drop this in the world. You're good. Has the floor and has outer walls. So note that this open array prefab, you'll use this like in the soccer game, in the combat game next week. So you'll come back and use this and add to it. I'm just gonna save my scene. So I'll go back to my application, go to soccer. Where did I made? That's weird. I thought I just made 2 more folders. Where did I make the folder? I thought I made more folders. All right, I'm going to just collapse that. I'm going to put this, just for the sake of argument, I'm going to put the soccer ball folder into the soccer folder here. So that makes sense. All right. So I'm going to create a new mono behavior script, and this is going to be our rigid body mover. I'm going to create another script here. That's going to be the soccer. Soccer ball. And then we'll create one more script, which is going to be our soccer. So this will, so the rigid body movie, we'll build this week. And then like for combat, we're going to take the guts of this and copy it over into a new class. Let's just, for sake of argument, let's go to our lab 4 and let's get our smooth movement. All right, and I'm basically going to take the internals of this class and I'm going to copy it. I don't need you guys open. All right, I'll go to the soccer and go to rigid body. All right, so the big thing, we'll keep move speed, rotate speed. All of this is perfectly fine. The one thing that we will add to this script is going to be the rigid body. I'm just going to use RB. And you'll see this is very conventional with Unity developers, that they'll just call this RB. And on start, we'll get the rigid body, RB. And we'll go to our game object, add component. Now, add component uses what's called templates. So you see these angled brackets inside there. It's going to ask for what component. So it's like, hey, T, what components? So in this case, it's going to be rigid body, and then you do need the parentheses and then a semicolon. And that's basically, we've now, if this object has a rigid body, we will get it. Now I'm just going to go in right here. If we don't have a rigid body, debug, I'll use error in this case. And we'll do game object.name. So you can get the name of the object. You can also set game object names as well if you want to. So this is a property you can set and get the name. So right now, again, this will if we don't have the rigid body, it will say what object it's on. So for our purposes, this is pretty much, north movement. We'll come back. We'll upgrade check input. This will become check input player 1. But basically all that, I've got code here for strafe player. We're not going to use strafe player. But in this case, move player basically, in our case, we're only going to, again, we're using Yeah, we're only using a single value. We'll talk about this. This is okay for our purposes right now. Yeah, well, so in this case, we won't have to. In fact, we'll take away strafe player for our purposes right now. Rotate player is not going to change. That you will find that with the physics system, you're not necessarily you're not typically doing you're doing a specific rotation that you're controlling. You're not doing it through the physics system. So this is not going to change. But the code here is going to change. Again, we're our game object transform.forward. So we're going to take out the position here. Let's just isolate the code. Right now, what we're looking at is the value times move speed times game object transferred forward times delta time. That was the delta of what we changed each frame. Because we're using the physics system, we don't need to use delta time. So we just have to just multiply by value times the move speed times our forward direction, and we should be good. And that's going to be our rigid body dot linear velocity. And literally that just changed. That's all that we need to do with our code. I'm just going to clean this up just slightly. There we go. Okay. So we just have to say what direction, what direction, how fast. All right, I'm going to go back into Unity. Let's go into Unity. Let's set up our, let's go to, there we go. Let me see, common assets. So we're going to grab him. We'll put him at 0, 0, 0. In this case, we'll put him 3 units. And for our purposes, we'll rotate him so he's facing 270. This will be player 1. And I'm going to put, just for argument right now, go to the soccer, put rigid body on them. I am going to duplicate this one. This will be player 2. Rotate them 90 degrees and move them -3. And just so that we know the difference between the two of them. So I got player 1, player 2 set up structurally. We'll come back for the properties on player 2 in a moment. So let's go to player. I'm going to turn off the rigid body movement for one moment. So we're only doing things with the first player at the moment. So if so the first thing I'm going to do is I will press play. Let's bring up the console. And we'll clear all those out. Those are old issues. And you'll see that they flopped over. Why? That's interesting. Did I add component? Yeah, so all right. I did something silly. I added the component. So the other way you could deal with level designer, you can just add the component to the object and do what you want. Not necessarily what I wanted to do, show off. What I wanted to show is get component. Let me take that out. There we go. Okay. So let's go back. So in the last case, I added the component, and when I got the component, clear. I got to look at what those are. So in this case, when I press play, you're going to see that in this case, no rigid font on player 1. So it didn't find the rigid body. So let's go back. Let's just add the component. And we'll take rigid body. This is going to get interesting, actually. When we play with the net, this will get interesting. We'll deal with the net later on. We'll talk about that later on. But again, now I've added the rigid body. We'll press play. In this case, bloop, bloop, down it goes. And that's because the physics is in play. Again, the constraints here, we forgot to turn off the rotation. And for good measure, because we don't want them, they're not jumping up and around, we're going to leave Y. Is this Football Manager the new Football Manager? Absolutely not. Why do I bring this up? Because they're shipping because they're using Unity now and they ship, I think, next month. So, not next month, early November. So yeah, Football Manager, this is not. All right, so now that we've got that in place, now we look at what's going on. I click in here. He's not going to fall over. And now if I use my keys, he is moving around. And you can see, and there's a little bit of slidiness to the system. So how would we affect that? Well, we can, after checking input, we could say here, rigid body dot linear velocity is going to be equal to vector 3.0. So we are going to assume that we don't have any movement until we assign movement based on the north and south movement code. So they're not sliding around like in this case. And let's go back and look. So we can see. So here it is, when I let go, it's snapping. So things to think about. If you wanted to build something like in space, I mean, that would you need to start building materials so that you are sliding. So sliding, there's no friction. Basically, what's happening, why it's coming to a stop, is because of friction. And so that's something you'd want to play with the materials. That's something to look up. Yeah, look up physics materials. All right. So we got player 1 moving right now. All right. Let's get player 2 up and running now. So if I go back to player 2, I turn on the script. And I don't have the music. And I forgot to set player 2 with the rigid body. Yeah, player 1, here's player 2. Add component. Rigid body. There we go. And there we go. Set that up. Off we go. And you can see that now I've got synchronized movement between my two. And then insert your Nutcracker music or whatever ballet that you want to, or synchronized swimming music. Cool, but not what we were looking for. So let's start. There's going to be a little bit of code work that we need to do. All right. So first thing is order of, when we look at, let's go to player 1. When we look at where properties that you can edit in the editor, the order of how they are listed in the script is what they're going to show up. So I'm actually going to do a public Do a public int, player input number. And I will assign that to, I'll use 1 for our case right now. The next thing I'm going to do is I'm going to grab check input. I'm going to make this P1. And then I'm going to grab this whole function. I'm going to copy it. And I'll just rename this to the name, rename the function to P2. And then player 2 is going to be IJKL. So north is I, south is going to be K, east is J, and this is L. So I've got my second player controls built in. So now all we need to do is basically, we're going to need a new check input. Int player, let's call it input number. And basically it's going to be an if input number is equal to 1. I'm just going to do check input player 1. And I'm going to do return right here because I don't need to check anything else. Literally, and I do need to close the brace here. So again, this is a style where you're going to have multiple ifs. You can do it. You know, if I'm calling like one line of code or setting one thing, you'll see this show up. And then I'll do input is equal to 2, and I'll just do player 2. And it's a condensed version of what we're doing. That's just all that we need to do now. Just grab our player input number and pass that to check input. You're on your way to doing more work. We're a few steps away from how you would actually write your code later on. This is at some point, all this check input P, all this is going to come out. Eventually, will come out of this class. Just going to give you right now that like the code we're writing right now is temporary. It is because we're writing it all in one class. But later on, I'm going to show you a technique, and I'm going to give you actually two new classes that you'll use that will simplify the code that you're going to need to write. And it'll also remove the responsibility. Right now, our class has the responsibility of checking the code, getting the code, doing that pooling, all that work. And you can see it's a lot of like lines of code already. Like there's like about 40 lines of code just from check input down to check input player 2. That's 40 lines of code we can pull out and put into another class at some point. And we'll look, and you'll be given the code for that because it's busybody work. And the structure of it makes sense when you understand what's going on. When you see it, it's easier to read it and see it than to write it first time. So now I've got my rigid body movement. I just need to go back to Unity now. And player 1's already set up. I just need to go player 2. I'll put in the new input number. And off we go. You see that second player is not moving around, and now they are. So hooray. So far so good. We've got our players up and running. All right. Let's go back to our project. Let's go to the soccer. Oh, it's weird. It's not seeing it. Okay. Let's go to the soccer ball. Let's bring in the prefab for it, and we'll just shove that into the world. See how big it is. It is small. That's super small. Wow. That's hilariously small. I think I need to go 5 by. Yeah, we'll do 5. Do 0.5. There we go. Okay. Yeah, that's bigger than it should be, but for our purposes right now, I mean, what we're going to be doing in our purposes here, we'll just collapse all of this. I'll just add the rigid body. In the case of the soccer ball, we don't need to play it with any of the constraints because we do want it physically to play with the rotation. I'm going to take player 2, and I'm just going to move them over to the side, so that just with player, so I can do test player 1, be like, hey, and there we go. Off we go, and then we can test that. In fact, what we are going to do, so we know that so I'm going to grab these. I'm actually going to move these a little bit closer because they're basically going to put a soccer net here. Let's go to our soccer ball one more time. Collapse the rigid body because we don't need to put any properties there. We do want to put the soccer ball script on it. Now the script's not going to have any properties that we need to set. It is going to have 2 things. Let's go to our script. Let's go open the soccer ball. We won't need start. We won't need update. I'm just going to repurpose update and just call this reset object. Actually, we do need to start. My bad. Actually, we do need to start. My apologies. We're going to get some stats on the object when the game starts. Take out these comments. There we go. We need to know it's going to be a vector. Oh my God, come on. Vector 3. Starting location. And we'll just we do need a quaternion. Now, we're not, it's going to be starting rotation. And for the quaternion, dot identity is basically essentially the 0. So just roll with it. Typically, you're not going to be affecting the quaternion directly. For our purposes, what we want to do is basically starting location is equal to game object, transform.position, and then starting rotation is going to be equal to transform.rotation. So this is the one case where we're actually going to store the rotation as a quaternion. Because ultimately, the first thing that we're going to do is when we reset the object, these lines are just literally going to be flipped. Just going to So when we call reset object, we're going to basically set the position rotation of the object back to where it is. We're not done yet. There's more code that we need to write, but you have to see, we need to see the soccer ball in action, and this being called first before we need to write that code. So we'll put a pin on that. We'll come back to that. The soccer net. I'm going to write the soccer net code right now. And this is literally this is the case where we don't need start or update. I'm just for the sake of argument, I'm going to make a public int team number. All right. This is so we can track which net we're looking at, which we're not going to use. We're not going to use for a while, but we have it here now. And this is the only function we really do need in here is going to be the on trigger enter. And the first thing I'm going to do with this is with on trigger enter. I'm going to basically for debug purposes, I'm going to do debug.log other game object dot name. Do plus, and then there'll be a space, and then we'll have entered net for team, and I'll just put the, for the sake of argument, team number, so that we're actually using it. We'll come back to this in one moment. So let's set up our soccer nets and see what enters the nets. All right, so let's go back to Unity. All right, and I'm gonna go grab soccer net, and I'm gonna leave this huge for our purposes so that A, the ball is clearly can get in, and B, the player can get in there by as well. I need to set this at -10, 0, 0. We need to rotate this one 90 degrees. So I think this one is 12, no, 13, do 14. So this is net soccer net team 1, and then I'll come back and build the other net later on. Just so while we're here, I'm just going to go grab my script, put the soccer net on there. All right, so what this doesn't have, I'm just going to open this up. Basically, there's a whole bunch of cylinders. There's a plane here. That's the top. You know, it's basically an open cube. What we do need to do, and I'm gonna do this the hard way, and this is we're gonna add a box collider, and you can see that there is that cube right there. All right. If I remember correctly, I believe the X is 8. The Y we're going to do 6. That may not be correct. I think Y is 4. Z is 6. There we go. No, Z is going to be, we'll do 3. I think the center, we need to move this up 2 units. Yeah, there we go. So it fits inside. We could, I think I'm gonna do 7. Just so the ball's so big, it's not gonna. There's not a possibility of it not, if it's on the wall right there, it'll be inside the trigger. We can do 7.5 just to be on the safe side. 4. I did 3. We do 3.5 just so we know. Yeah, that should be good enough for our purposes. So we just want to basically put the collision area, and we also want to click its trigger. I'm going to turn that off for one moment. I'm going to press play. I'm going to throw the ball at it. There we go. And it's going to go, and boom, hits an invisible wall. And that's because the trigger, it's not trigger. So we'll click that now trigger. We'll now play again. And then the ball goes in, and you can see the ball entered for the net for team 1. So conversely, we can go in the net too. And it found, in this case, found the capsule and it found the cube, which are the components of the first player. Let me collapse. So it found these two because that's where the collider is. Now, we'll worry about this later on. What we want is when the net sees the ball, it does something. And in anything else, it doesn't care. So the first thing that we need to do is make sure the net's only looking at the ball. All right, let's just jump in here. So we can ask other.gameObject get component of, in this case, we're going to ask for the soccer ball. So what we need is a variable of soccer ball. We're going to do SB because we're being lazy at the moment. I'll just call it ball. That makes more sense. So when an object goes in the net, it's going to ask, do you have a soccer ball script on you? And then the next thing that will happen is if you have a ball, do stuff on ball. So when the player goes in, it's going to check the game object with the cube on it. It's going to check the game object with the collider for the capsule. And it's not going to find the soccer ball. And this will be, if ball, this is going to end up being a null variable. And in this case, that null variable will revert into a false Boolean for us. That's something that Unity has coded for us again. This is a pattern I want you to be aware about because you're going to use this over and over and over again. It's going to be one of your friends. This is going to be a pattern that you're going to use in different versions like in Unity and Unreal and other engines. Because now we have the soccer script, we actually have a reference to the soccer script. We can go ball dot reset object. And it's yelling about me because it's inaccessible to its protection level. So let's go back to the soccer ball. What we did is we've got to make this public. And now that we've made that public, we can now go back to the soccer net and access it, which is what we want. So let's save this. But now let's go back into game. And I'm going to put the ball into the net. And that was a bad demonstration. Hold on. And you saw that it reset to position, but it kept moving. It kept rolling. So your position, your linear velocity. So what's going on is, again, we only set position. We only set its rotation. But let's go back to the soccer ball. It has a forward velocity still. So it's going to be, so again, in this case, what we want, we need reference to the rigid body. RB is equal to game object dot get component rigid body. And that, now that we got that, we can do rigid body, linear velocity. It's equal to vector 3.0. It's suggesting a line of code. It actually is correct. We'll come back to that line of code in 1 second. So I will press play. I will push the ball into the net. And you can see that it's still rolling. Let me try that one more time and get further. And you can see the ball is still rolling. That's because while we did take out its linear velocity, it still has an angular velocity, basically rotation speed. So we will then go in RB, and it is literally giving me the line of code. So angular velocity is equal to vector 3.0. And I'm stylizing this way because it looks nice. It looks like more like a table. Don't get me wrong, if you do and you type in the, it will undo that. So just be mindful. This can work against you. Visual Studio can work against you if you're trying to be pretty that way. It's stylized version of code. If you're setting a lot of things together, having that space, can make sense at times. So, I mean, that tab. So we'll save that. We'll press play. And off we go. And this is where things are going to get interesting really quickly because I'm not straight on. And right now, I mean, part of the big issue that we're dealing with is like the moment it touches the trigger, it's resetting it right away. And one of the things we could do is we can go back to the net, make this, let's say 2. So there's more leeway. There's more things that we can do, and later on you'll learn more techniques. So one of the things that we could do, like we could be respawning the ball, for example. Trying to think what else. His techniques to do a delay in the script and have it wait and then reset stuff. So we've got there's a lot of options of how to make this look nicer as we move forward. So right now we're something's happening, we're doing something right away, and for our purposes, for experience purposes, doing it right in that moment is not necessarily the best way to do things. Now I'm going to make the trigger just a little bit smaller on the z-axis, so when it will go in the net some bit. In fact, I can actually maybe even move it back 1 unit. So it looks a little bit better. Oop, I missed it. It does see that the capsule and cube, but doesn't do anything. You know, the only other thing that we could possibly do on the net is basically we'll do a public int team score, set that to 0, and then we can basically like, hey, team score ++. Do stuff on the ball. Later on, we'll come back, play a sound effect. And then there's things where, like, you know, again, if we go even further, like this object connects to another object to say, again, this is the net is holding the score in this case. Later on, another object would probably hold that information. A manager object that's going to be managing the gameplay type stuff. So we would tell them, hey, ball went in this net for this team. Give them a point. And this is the assignment for you this week. It's pretty straightforward. We are leveraging code that we've used before, so we don't have to write it all over again. All right. We've expanded what it does. We gave it, you know, gave it the ability to support more than one player. Why did I use a player number instead of a Boolean? Because later on we could support more than one player, more than 2 players. In theory, I could, I think right now, let's say in theory, we could do let's just look at the rigid body mover. And this is where, like your code, this is why this code is going to get pulled out of this class eventually. But we could say, hey, P3. This would be the up arrow key. I'm just going to go and just replace these because it'll be easier to do down, left, right. And we'll just add another line right here. Check P3, input number 3. So I've just added the arrow keys to keys on the keyboard that we can use. You know, in theory, let me see. I'm going to hold off on doing, so this would be arrow keys. In theory, let's do just one more, just undo that. We'll do one more just for the sake of argument. Number pad. So number pad, that would be 8. I'm just going to go in and copy and paste these. Because basically I'm just changing a single character in this case. South would be 2. The 4 would be east. And 6 would be the west movement. So I can now, we would be really cramped with 4 people up here each. But I've got now 4 different movement styles, 4 different keys that we can use, 4 different sets of keys that we can use to move our players about. I'll save that. Actually, let's go back. Make sure we save this. Let's go back up. Just make sure that I'm supporting it. So again, 4, 4. And this is code that you will see when we look at the input poller class. This is code that you'll be writing and adding, extending, and you'll be given the whole class. You know, the structure will make sense. Yeah, when we talk about it, it'll be basically what we're doing is we'll spin our input polling and getting input into its own system. And it'll be isolated as its own system so that if we won't have to worry about when we write our code, we won't have to worry about are we using a gamepad, are we using a keyboard, are we using a mouse. Just trying to think. I'm just thinking of weird things like let's use the mouse for movement of the soccer player. Let's do that for the sake of wackiness. Input player 5. We're not going to be using the keyboard. We'll be the mouse. So mouse. So north movement would be mouse. Left button is pressed. Mouse, right button is pressed. East movement, we'll look at, this is going to get, so it's going to be an if statement. So we're going to look at mouse. I think pointed delta is what we want. Delta, it is. So when you see an input control, like an input control, system.control, this is we're going to need a read value. And we're going to use Y. If that's greater than 0, now later on we'll look at this. This would probably use like a thumbstick, a vector 2 later on, but this will be the west movement is equal to true. Now we are using these booleans, but later on, and then the other one is if the mouse movement if it's less than 0. That's not what we want. There we go. Close that. There we go. It's less than 0. Let me take out this code because we don't need that anymore. The one thing that we need to do is to make sure this is going to be east movement. We could do an else statement here, but I'm just going to say up here before we consider the left right. We'll just do west false and east movement false. So if the mouse is not moving, then the delta basically is the change of the position of the mouse. So if its mouse is not moving, that'll be a 0. So none of these F statements. If it's greater than 0, that means we're moving from the left to the right. So we want to, that's our west movement. And if it's less than 0, it means it's moving the opposite direction. And then just so that now we've got that plug set up. Let's set it again. All of these are extra, not part of your assignment, but cool that if you do that. Cool if you get the gamepad up and working, because the gamepad will using the thumbstick specifically are going to prompt you to write your code in a different way. We'll talk about that. We'll talk about the gamepad another time. Right now, I'm just, I'm showing you. And again, right here, again, we started at line 63, and we're already down to line 152. We're almost 100 lines of code. That we will move again. We're going to extract that code and we'll put it into another class eventually. That's a little later down this. That's a few weeks from now. So don't worry about, I know this looks like a lot of code pretty quickly. I mean, we're already 163, 164. Take out that last line. So we're at 164 lines of code already in this class. This is gonna be normal. All right, for this class, this file is going to get big. We're going to write much more code in this. Basically, we're going to make from here. I mean, literally, the next week we're going to take the code out of this class, plopping into put the body into the new class, and extend and write more code. Could we inherit? We could. Or not. You're not at the point where inheritance makes sense in that way. So, I mean, we could inherit. I'm going to save this. In fact, but we won't, because right now, like how we will write some pieces of code. Yeah, like right now, like basically we're setting based on that key press. Basically, we're calling move player with that value. There'll be another way we handle this, and this will simplify the coding here even more. So, step by step, we will get there. When we deal with the gamepad itself, we'll use rotate and move player as they are. They'll be used differently though. So, out of weirdness, let's just go into Unity, and let's go to the second player. Set its input number to 5. Let's see if it works. Does it work? Sorta. I think we need to do. It works. Probably needs to go. I probably need 360. You probably need to double it. It's janky. Not the best control scheme. Yeah, not the best control scheme I've ever put together. Probably do 720. So it probably needed to be much higher to make it more. There you go. Yeah, rotation needed to be much higher. Come on. And in the ball it goes. Again, we'll just, finally, we can duplicate this. Team 2. Team number 2. Again, this is going to be rotated to 270, and then 914 on the other side. And there we go. Here's our soccer net for the other team. I mean, Football Manager. This is not FIFA or EAFC, but small steps. You can get there from here. Make sure you save everything. Save. Give me, the only scripts I need basically are these 3 scripts, and we should be good. You'll be good to finish the assignment. Any other questions before I let you guys stop the recording? Pretty straightforward. Look for patterns. Again, one of the patterns right here was with the movement. I mean, like, we basically added an input number. We added a rigid body. We got the rigid body on start. That's a pattern. And then we again, all we had to do was just change the move player, and we just had to just set the linear velocity. We wanted snappiness, so basically we set the linear velocity to 0 before we did any. So this is again. And that's, again, arcadey. Again, we're looking at different arcadey things right now. But, this is tactics that we'll use over and over. I mean, we could take this out. You get in a scenario where you don't have friction. So, Space Wars. The velocity of the object is not going to change. Basically, your forward movement is adding velocity. So right now, I'm actually going to grab these 2 functions and move these up to make our lives easier, so I'm not scrolling through everything. But in this case, we're assigning the linear velocity. In a game where you're like Space Wars, where you've got a spaceship, first of all, you wouldn't have this line of code to set it back to 0 because you want to keep the velocity. And that wouldn't be assigning, it would be adding. You're essentially adding a thrust to the, and this would be, all right, I'm just going to do this quickly right here. This is going to be move player, space. This is I'm gonna do a variable right here. This is not what you do, but public float max velocity. I'll set this to 15 for the sake of argument for right now. So this would be plus equals, and then the next thing you'd do in here, if RB linear velocity is greater than or equal to max velocity. Oh, dot magnitude, sorry. Basically, we're going to reset the linear velocity is equal to normalize times max velocity. So this is clamping it. And I'm just going to put parentheses around it just because I'm very notorious about using parentheses. I didn't need to, but I am being very specific. This is a mathematical operation. So I tend to, and I've been yelled at by Visual Studio and other IDEs for doing that. You don't have to use the parentheses. That's not necessary. I'm paranoid. Don't tell you right now, a little bit of paranoia in writing your code is good for the soul of the programmer. Unless you're doing multiplayer networking, then it's full-blown conspiracy theory. Do not trust whatever the user's telling you. Trust but verify. Maybe. Sometimes. Yeah. When you're dealing in a network scenario, when you're getting information from another location, particularly like the player, you never trust that information. You got to go through and make sure everything is correct, everything's valid. You're not, and as you get further into cybersecurity, there's ways you have to write your code to be secure. In cybersecurity, it's not paranoia. It is full blown. It's not a little bit of paranoia. It's full blown paranoia, and they have to. It is, they don't trust anything from they assume in cybersecurity, they assume the data that you are going to get from a client is garbage from the beginning, and you have to verify it's not garbage before you use it. Yeah, there's ways where when you allocate code, one of the techniques is that you internally allocate the code is allocated in a particular way that is secure, that the client can't then muck around with it. Again, like another thing is if you give them a string that you're looking for information, that string doesn't have it's sanitized of information, so it doesn't do random things. The information you're getting is clamped to, if you are only taking 50 characters, you're not getting a string that's over 100 1,000 characters and running obscure code for some reason. And this is definitely an off tangent. I forget which there's a webcomic popular among tech people, and that and those who know about Little Bobby Tables, and all you have to do is XACD, I think is the comic, but you just look up Little Bobby Tables, and you will find the comic. There's a command called drop tables in SQL and other databases. Yeah, they named their child Little Bobby drop tables. It's their middle name, and that is an SQL command that, in theory, the school then had a problem. and the administrator's going like, why did you name your child this? And the response from the parent is, why did you not sanitize your inputs? Yeah, little paranoia for the soul is good. There you go. Make sure I save. All right, I'm gonna stop the recording here. I don't think you guys have any questions. I've gone on a tangent. For those who are watching this, who watched these last few moments, I hope you enjoyed the humor. But yeah, this move space. We're just adding value. We're making sure we're not going too fast, because you can go fast really quickly. In fact, the movement speed that we have here for 5, probably 0.5, maybe 0.2, because that will add up really quickly. Yeah, that will add up. That will add up really quickly. So, actually, that might be frame. That might be, yeah. Well, yeah. Again, you'll as you build these other types of games, you'll encounter those issues. All right, I'm gonna stop recording right here.